Hello, this is our fourth and final video of Chapter 6, Section 4. And on this one, we're looking at another special case expressing the solution of a system of dependent equations containing two variables. So what does that mean? Well, it means that basically the lines not only intersect, they intersect at every point. But what does that mean? That means they lay right on top of each other. So what we've done so far, we've seen two linear equations that in the first two videos, we showed that the two lines are actually crossing at a single point. Okay. The third video, which this one was the inconsistent system, and that's when the lines are running parallel to each other and they don't ever cross. And we saw in the third video what occurs in the algebra when that happens. You get a number equaling a different number. Okay, so when you get different numbers, you got two numbers set equal to because the variables are eliminated on both of them, and you end up with an untrue statement, that tells us it's inconsistent. Well, this is playing on the same lines as the third video, but the only difference is when you do this, the actual numbers are actually going to be the same number. So yeah, the x's and y's are both going to be eliminated on this one as well, on dependent equations, but what the result is you be two numbers that are always the same. Like, for example, 5 equals 5, negative 6 equals negative 6, or 0 equals 4, or something like that. 0 equals 0. So those are the situations that when you're going to have the same number. So when the same number hits each other, they are basically a dependent system. Okay? So this is very similar to the third video in the process. So what you're going to do is pay attention. Do the numbers equal to each other, or do they don't equal each other? If they don't equal to, then the system was inconsistent, as we showed in the third video. When they are the same number, then it's a dependent system. And the problem is, how do you write the solution? And that's going to be our objective here. Okay, so let's get started here. Okay, solving a system of dependent equations. And again, on this one here, we will not know it's dependent going into the problem in your homework, in your quizzes, and in your exams. Okay, you won't know that it's a dependent system. In this example, we know where we're going. Okay, but in the instructions on an exam, it's going to say solve the system if it exists. So that's what you got to pay attention to. Okay, so solve this one. It's 2x plus y equals 4. Negative 6x minus 3y equals a negative 12. So let's look at the solution. So we're going to choose this method. We're going to do the method of elimination, looks like. Yep. So what we're going to do is we're going to multiply the top equation times 3. So if we multiply the top equation times 3, that's going to have 6x plus 3y equals 4. Second equation just comes over. So it looks like the author here decided to try to eliminate the x's. But look what happens. The x's cancel. The y's are also cancel. Sometimes I call that collateral damage because you meant to cancel one thing, but they both canceled out. So a lot of times I'll call that collateral damage. But you end up with 0 equaling 0 when you add the equation up, because everything gets canceled. So 0 equals 0. So the goal here was to eliminate one of the variables, but what ended up happening then is all the variables are eliminated. Now, just like in the third video in this section, 6.4, and you get the x's and the y's both gone. But then you end up with a number equaling another number. But this time the numbers are the same. Okay? So in the third video, you ended up with like 0 equals negative 2 or something like that. And that was when they are not equal. So it was a system that was inconsistent. So the difference here is that now the numbers are going to be the same number. So what that's ultimately telling you is that the two graphs are the same graph. They are laying right on top of each other. Okay? So what we need to do is figure out a way to understand how to express the answer. So what we're going to do is, it says the statement 0 equals 0 is true. This means that the equation x plus 3y equals 12 is an equivalent to negative 6x minus 3y equals negative 12. Therefore, the original system is equivalent to a system of containing one equation, so the equations are dependent. And we talked about that in the first video of this section as to what it means by dependent. They lay right on top of each other. Okay? Okay, this means that the values of x, y that satisfy that one will satisfy the other, in other words. Okay? So there are, in fact, infinitely many values of y, and of y which 2x plus y equals 4. So the original system has infinitely many solutions. Now, when they say infinitely many solutions, some students will translate that into saying the solutions is infinite number of numbers. No, that's not what it's saying. Because it can't be all real numbers. Because if it was all real numbers, you're basically saying every ordered pair on the Cartesian plane satisfies the equation. And that's not true. It's only the ordered pairs that are on the line. Because remember, the lines are on top of each other. So if you have one line, you have another line laying on top of each other, then there is an infinite number of solutions. Yeah, but it's the ones that are on that line. If the point is not on the line, let's say it's over here off this line, you got a point over here, and the line is running through here like so, and you got the point here, that point is one of the points on the Cartesian plane, but it's not a solution because it doesn't lay on that line right there. So that's the idea. You have to lay on the line. So yeah, there is an infinite number of solutions, but it's only the solutions that are on the line. That's where a lot of people get confused. So when they see 0 equals 0, say, oh, that's the dependent system. So they immediately translate that into saying, oh, then it's all ordered pairs or infinitely many solutions or all real numbers or something like that. But you can't say that. It's only the ordered pairs that are on the line. So you would say, well, y equals negative 2x plus 4, or you could just say x equals 1 over 2y plus 2, whichever you want to solve for. But look at this last part. This tells us how we write it. It says the solution is also expressed as the ordered pairs x, y, such that y is equals to negative 2x plus 4, where x is any real number. And that's the one I'll prefer. And they give you another one on the other one, but the first one here is the one I prefer. Okay? So the solution is expressed as the ordered pairs x, y. So notice that they're not saying all ordered pairs. They're just saying the ordered pairs such that y is equals to negative 2x plus 4, where x is any real number. So if you take any real number for x, put that in for that equation, you get the ordered pair. That ordered pair would lie on the line. So yeah, there are infinitely many solutions, but it's the solutions that are on the line itself. Okay? That's what we call set builder notation. Okay? Set builder notation. Okay? So it's the ordered pairs x, y. Now the other one is the same idea, and I don't really know why he would even show you this one, but it's the ordered pairs such that x is equals to negative 1/2 y plus 2, where y is any real number. Okay? And it's fine. You can do that one. Basically, it's just depending on which one you want to solve for to find the ordered pair. If you know the x and you want the y, then you would use the first one. If you know the y but you want the x, you got to use the second one. So that's the idea. And let's look at the graphs on these. Now remember that on the first couple of videos, we were looking at lines that had one single point after we saw the graph they crossed. The third video, we saw two lines that are running right beside each other. So what do you think the graph is going to look like on this one? Let's look at it. Notice the line is purple. Okay? That's not a coincidence. And the reason it's purple is because, remember, on the other video, there was a red line and a blue line that were running parallel to each other. Okay? And it means that they don't cross. But what does red and blue make? It makes purple. So what they're showing you here is the red line and the blue line are the same line. Okay? So that makes purple. So the two lines, that's why you don't see two graphs here. You're basically seeing you're basically seeing two graphs at the same place. So these are dependent system. Okay? But the big thing here, guys, is to understand how to write the final answer. So the difference in the third video and the fourth video is the third video is showing you two lines that are parallel that is inconsistent. And that happens when you try to solve it by substitution of the elimination method and the numbers are different, like 0 equals -2. And then the last video here turns out to be the same thing, except the numbers are the same. So the last two videos are kind of similar in the process of getting the answer, but what happens is at the end result, when you get two numbers that are different, you have inconsistent. And when you have two numbers that are the same, like 0 equals 0, then it's dependent. The biggest part of the problem of how to express those answers on dependent system, because if it's inconsistent, all you have to say is it's inconsistent, or you have to say it's no solution. Okay? And that's all you really have to do. The hardest part of here, you can't just say, well, it's a dependent system, which is true, because I'm looking for the solution, though. So if I'm looking for the solution, you can't just say dependent system, because that just tells me that they depend on each other. But you got to kind of tell me what that answer is. And that's where the bottom lines are telling me. It's all the ordered pairs x, y, such that then y equals -2x plus 4, and let x be any real number. So that's the important thing of how to express the answer. Okay, and I'll be looking for that on the exams. Okay, so that concludes the fourth video here, and it concludes all the videos of Chapter 6, Section 4. And so, but as always, if you want to see more examples, you know how to contact me. And as always, you have a good day.